Welcome to Crypto 4.0 Artificial Intelligence. Our channel main objective is to clarify the artificial intelligence methods and make easier your understanding to apply such knowledge for financial asset prediction prices and choose the right financial assets. We are assigned to apply our knowledge for crypto coins price prediction. Please note that our objective here is not to give you any financial advice, rather than give you a clarification about how you can use the different artificial intelligence methods for your price prediction of your crypto coins and other physical assets, as well as choose the best crypto coins and other physical assets for your finance portfolio. My name is Dr. Eduardo Calixto. I am a reliability engineer since the last 22 years. My work was basically apply statistical and mathematical methods for prediction of equipment and product reliability. In the last 4 years, I developed those skills on artificial intelligence, and now my intention is to apply such skills in finance and enable the application of such methods for crypto coins prediction, classification, and clustering. So the first method that we will clarify for this crypto price prediction classification is the machine learning. Machine learning is one of the methods that we have in artificial intelligence. And the main concept is you select your data set. For example, you have 1,000 price for bitcoins, and then you need to split this 1,000 data for training data sets and test data sets. Usually you split these data sets in the range of 70% for training and 30% of test data. You can also use 80-20, depends on your choice. And then when you split this data, you have a model. For example, when we are looking for prediction, we use regression models that you see later in the presentation. Then there are different models that you be applied in this training data sets and the test data sets. Then the model will predict, will come out with a results, and these results we need to verify and see how good is the result. And then if we get a good result, we can apply this model for a new data set. And then, as long as we have a good data result in this prediction for a new data set, we can validate our model. We need to be careful with two artificial intelligence concepts. The first one is overfitting. If your model prediction have almost perfect fits on the data sets, in the trained data sets, that means your data is overfitting. That means you can measure that based on error. If they predict values based on their model compared to the real data, the error is very small, your model is overfitting. What's the problem of that? If your model is overfitting, when you have different data sets, probably you have a bad prediction. By the other way around, you need to be careful with two other concepts. Underfits data. If your model is underfit, means you have a high level of error in your prediction. The other two concepts that we have in artificial intelligence is bias and variance. Bias means when you define the variables that you use in your model. For example, in our case, we are trying to predict the Bitcoin's price, and that's one variable, independent variable, the result that we want. And we choose as dependent variable the volume of transaction, the market cap. You need to choose this dependent variable that have a good relation to get a good prediction of price. If this dependent variable have a low relation with the dependent variable, if, for example, that's not the case, but if you choose variables that have not relation, you have a high bias. If you have good relation, you have a low bias. And the other point is the variance. The variance is another important point that shows the difference that you get from the training data result and the test data result. So you need to, in the end, to choose a model that have low bias and low variance, and that's the challenge. And then I will show later on how you can select a better model. Before starting to dig into deeper in machine learning, I would like to make some clarification about the concept. So, as I mentioned before, artificial intelligence are application of computer based on mathematical methods and algorithms to deal with data and provide information such as alert, classification, and prediction. And this alert, classification, prediction in our beginning here will be done based on machine learning. Machine learning are artificial methods that also apply mathematics and statistical methods that use data to provide cluster classification prediction. On the beginning, I thought to put all this information in one presentation, but I realized that it's too much information, and the intention of our channel is to make it easier for everyone to understand the concept of machine learning and apply in your daily basis for choose and predict the price of your financial assets. Therefore, I will focus on regression or prediction first, and then later on I will do again one specific video for classification, another one specific video for cluster. For each one of these machine learning methods, I will present some examples, and then I will provide different examples for the video for easier learning process. So we have basically three different types of machine learning. We have unsupervised machine learning and supervised machine learning. Unsupervised machine learning are methods that have no previous information of the data, but group the data in clusters. We will see that cluster is when you group data based on specific characteristics. For example, you can cluster the bitcoins in the market cap, high market cap, low market cap, and middle market cap. You use this method to cluster them. And then, of course, the advantage of machine learning that as long as you get data as inputs, your model will cluster such groups of crypto coins automatically. That is the advantage of artificial intelligence. This process, once you run your model is validated, they will repeatedly do the same sequence of actions. The algorithm will constantly clustering or classifying or make prediction based on the data that's coming in as input. Then this is unsupervised machine learning, but you have supervised machine learning. Supervised machine learning have a previous information, so meaning you have past information, use data, and the past information to perform data classification. And then data classification, you can classify the data, the crypto coins as high market share, low market share, middle market share, or for example, high. You can make this is already clear, the market share classification, but you can classify if you can classify based on your prediction how much these crypto coins will appreciate. You can classify as high appreciation, medium appreciation, and low appreciation. So that's very important because along the time the hierarchy, the list of the ranking of these crypto coins changing based on market cap and volume of negotiations. And then the idea is that you have some models that can cluster and also classify the cryptos that you have a high appreciation. High appreciation means how much percent you get from your investment. So you invest 1,000, the crypto price goes 5 times, you have 5 times appreciation. And then of course you can classify what is high, what is medium, what's low. You can put, for example, classification low for between 2 and 5, classification medium between 5 and 10, and high appreciation when is over 10. This is a classification. And then of course you have the supervised machine learning classification that's defined based on category. You create categories for your data, and then what your model is going to do is the learning based on the classification that you proceed, and then whenever the data change, they will automatically classify that, and then you always know which one will be the ones that have higher precision, medium, and low. And depends on the risk that you want to face, you make your choice to allocate your resource and have these crypto coins in your portfolio. And then, of course, the one that we start is supervised machine learning regression. And supervised machine learning regression method aims to predict future data values. So you have here continuous dependent variables based on past data knowledge about dependent and independent variables. So meaning, as I mentioned before, independent variables are the results, the variables the values that shows the result that you want to predict. A variable is a characteristic of a population. For example, price, you have a population of crypto coins, and price is one of characteristics. And this is an independent variable that you want to predict in the future. And then you have dependent variables, that is the one that influence on the price. For example, market cap, volume of negotiation, and so on. These are independent. Then you need to choose the right ones, the ones that have a very relation with the dependent variables that have a very relation with independent variables to make a good prediction. You have also the concept of continual dependent variables. Continual means that you cannot define a specific value. So the price of the coins, you cannot predict exactly what will be the price. The price always have infinite numbers between 0 to 1, 1 to 10, and so on. You cannot count in exactly what it will be. Like the time that's you arrive in your workplace, for example, there will always be different times. You can take 30 minutes, 0.1, and if you put in seconds, there will be always difference. That means continuous. But that's not too relevant. It's important to understand concept of independent variables. Independent variables, in the end, your independent variables, the result you want to know, and for prediction will always, here in our case, will be the price. And then we need to define the dependent variables that are related with that. So an overview of artificial intelligence, as I mentioned before, artificial intelligence has different fields. We are focused on the beginning in machine learning because we want to predict the price of our crypto coins. We want to classify our crypto coins. We want to cluster them automatically in the future. So that's why we are applying machine learning. Another field of machine learning of artificial intelligence that we can use later on is natural language processing that have sentiment analysis. And sentiment analysis we already have in the website. If that shows one graph that shows how is the users sentiment about if they are bearish or they are bullish relate to some crypto. So this is a kind of sentiment analysis that we can also produce. This is a method that we have in artificial intelligence. But we'll focus on the beginning of machine learning, and this video is about machine learning regression. So again, the supervised machine learning regression. Regression means I will predict the future values based on the past values. And then, what's the difference? I can do that in Excel. I can do that in different tools, mathematical tools, statistical tools. Why am I doing that using artificial intelligence? Firstly, artificial intelligence has different and more sophisticated methods to make regression, to make prediction about the future price of crypto coins such as Bitcoin or others. The other point is that the difference that we have in artificial intelligence, that this process is trying to be done automatically. You don't need to always to include input data or change your model. No, the model, as long as you have a data set, you train this data set is validated, then whenever comes new data, the model will automatically assess and predict the price of these assets. So as I mentioned before, here now we have a specific regression model, but the concept is the same. You have a data set. Again, in my example, we have 1,000 data from Bitcoin or Ethereum or Solana or Hedera, HBAR or others price. Bitcoin is the one that you have a range time of data. So since, if I'm not wrong, since 2017. So you can collect this data in a website. Then what you're going to do as a first step, you need to prepare this data set, see if there's no any gap in this data set, and then when this data set is ready, you split this data set. As I mentioned before, usually you split the training data set is 70% of total data set and test data set. And then the algorithm, they get this 70% randomically. And then they will apply some regression model. We know the most common regression model is linear regression. And then they will predict they will have a result of prediction for training test data. And then, of course, you verify the error of this prediction. And if the error is acceptable, you can use this model for new data sets. And that's the idea. So we have data from 2017 to November 2024. And now we want to know what's going to happen in the next future. So that's the idea. That will come the new data, and I will show an example how you can do that. And then, of course, you validate your model, and you always use this model for prediction. What's very important here is to be aware about which are the best, the model, regression model that have the smaller error. That is the ones that have the better, the model that have smaller error is the model that have the better prediction. So that's the idea here. So let's talk about our first method here, supervised machine learning. So basically, a regression model considers at least two variables, independent variables and dependent variables. In our case, the independent variables will be the price of the coin, and for example, as a dependent variable, you consider market cap or volume of transactions. We have in our case two variables. We can have more, but graphically we can represent it in two dimensions when we have two variables, or in three-dimension maximum. But of course, when we are doing regression, we can have as much as dependent variable as we believe that need to be considered in our problem. And then the whole idea is by considering different combination of price of Bitcoin, for example, and market cap, we'll try to find the equation that better fits these points in the space and minimize the distance. So that's the usual approach that we have in linear regression. This linear regression indeed have some important parameters. One of the important parameters that we call correlation coefficient. This is very important because this correlation coefficient, the value is between 0 and 1. Closer to 1 means there are very good correlation between independent variable and dependent variable. That means the error of your measurement is very low. And that's basically the equation that you consider to calculate this whole value. This is mostly automatically, basically automatically calculated in many softwares. Even in Excel you can get this whole value for your regression model. Another very important aspect in measurement index is the mean error. There are different mean error. I will focus on one mean error that's called root mean square error, and that's basically described as this formula below. So it's a rooted the square error distance. So basically, I will consider the difference between the predicted value, the real value, square, and make the summatory of that and divide by the total number of points that I have, and it's squared, and that gives you the measurement of error. And then this index is very important because that will give me the real idea which are the best regression method that is fit on my data, and the one that's have the lowest root mean square error is the one that will better fit on my data. And this is the one that I will use for make my coin prediction. In our first case example will be the Bitcoin price prediction. As I mentioned before, we have different types of regression methods. The first one that we're looking into was linear regression, but we will have different models such as stepwise linear regression, spot vector machine, Gaussian regression, neural network, tree regression, and others variants of this method. So I just give some main examples for you to have an understanding that there are different methods that can be used to make this regression, this prediction of our coin price in the future. So the first method here for you to have an idea is clarification stepwise regression. So basically stepwise initiates the regression equation with only one coefficient. The idea is to identify which independent variable, for example in our case market cap or volume of coins that is sold or other parameters, how are significant such independent variables in our prediction of our price. And then this is what this method is about. So the method have an algorithm that makes statistical tests, and then they choose, they aim on this x1, x2, x3, x4. In this case here are dependent variable. They choose always the one that have the highest statistical significance. That's meaning this x3 variable here, dependent variable, have significance relation with the independent variable. So market cap have significance relation to the price prediction. Then the model pick up this one. The ones that have the lowest, for example x1, will not be added in the model. Then different from the linear regression that I choose myself which are dependent variables that I use in my model, the stepwise linear regression, they perform statistical assessment of each one of dependent variable and tells you the ones that have significance relation with independent variable. And then we expect to have a more reliable prediction. And the question is, what is the t-statistic? So just for clarification, we have here standard error of the coefficients. We have the t-statistic, that is the relation between the estimated parameters divided by standard error, and the p-value is for the t-statistic is hypothesis test. And the hypothesis test, whenever this coefficient is closer than 0, in this case I will add, and as much as far away from 0, lower than 0 is not significant. So this is a very good model because the dependent variable that have significance relation with independent variables. So in other words, I want to predict the price of coins, and I consider 5 different other dependent variables. I consider cap, volume of transaction, and I consider, for example, the inflation. I can consider the gold price. Then the more step is you tell me, okay, for your price prediction, based on this data that you have, the market cap and the volume of transaction are the two variables, dependent variables that have a high correlation with the independent variable price. The other ones are not significant. The model by itself will exclude the other significance and make a better prediction. So now let's step through this model that's so-called support vector machine. And support vector machine is have some similarity with the regression model, but here the difference is in the regression model we define one regression line that we try to minimize the points that go through equation that go through this point. Here we define what is called so-called tubes, and these tubes consider an error margin from this equation here for to below and to upside and to downside, and this is formed by considering the minimum distance or minimize the distance for the points to this line here, and then in the end some points will be outside of this equation. So rather than consider only one line, this support vector machine for doing the prediction, they consider the region, the tube, this region, consider this this let's say this error detection. That's different that we have in this model. The next model is a Gaussian regression. In the Gaussian regression, the idea is that for whenever you collect one point for crypto prediction, you actually not have one value for day. You have more than one value, and that's happen on reality. You have different values of a price of a coin in a day, and what the Gaussian concept is that you define different functions, and these functions have a mean and standard deviation for the value of their prediction. So as we know, as I mentioned before, you have a price of Bitcoin during the day. They have the minimum price, higher price, and the closest price. But the idea that you have a normal distribution, that you have a mean price and standard deviation. Then, of course, you apply this concept. If you're starting to have different points along the day, you have one function for a maximum price, you have another function for the minimum price, and have another intermediary functions here that we can see in green and in brown here. So that is defined for this function. Then, of course, consider all these functions. You have a mean and standard deviation, and then, of course, you have a region here that gets the mean value of all these functions together. So that's why Gaussian regression do, and that's very close what we have for an idea to coin price prediction. The main point here that we cannot forget, despite of the concept very well, in the end of the day, I need to always check my root square mean error and check and compare these three models. For example, based on the data that I have from, for example, in our case, the price of Bitcoins, if the root mean square error comparing linear regression, support vector machine, and Gaussian, which one have the less root mean square error? The one that have the less is the one that fits better for these data points, and that's another aspect. That's do not mean that will always be this specific model. Maybe in 3 months, based on the data changing variation, the result of this assessment shows that now is not the support vector machine that's the best method, but now is the Gaussian one, and that is constantly a dynamic changing along the time, and that is the advantage to have artificial intelligence by applying your prediction, because this assessment will take place constantly and automatically. Another interesting model is the tree models, and the tree is basically they define intervals and where you define your predictions. So you have the algorithm will build a tree diagram that shows here, and then of course you have different possibility. That is the result 1, 2, 3, and 4. And depends on the values of the variable that you are considering. Your prediction will be in a specific place. It will have a specific value. So here, for example, you can see that's the first point, 0.3. So if it's higher or lower than the 3 points, we have different results in here. And now if it's if I have lower than 3.2, I have R1. If I have higher than 1.2, is another point, I have R2, and so on. And then of course they always consider here these quadrants. What's R1? If it is interval here, if R2 is the prediction will have this interval here. So in our case, for example, if we have a market cap in a range of value and the volume in a range of value, for example, this range of value, let's say the market cap is 3 billions, between 3 billions and 2 billions, and the volume is it's something between 0 and 3 millions, I will have the classification H2, and H2 will have a specific value. That is we need to point out here that for regression, usually this is not a very good model, the tree model, because they repeated a lot of similar values whenever there is the data are inside some range. And for classification, we will see that is a better model. And of course, we have another very applied method is neural network regression. What's the idea of neural networks? So we need to take a look on it here with more attention. That's the neural networks actually mimics the human neurons. So the idea behind this model is that the neurons, as a human neurons, that pass information from one neuron to others. This model builds in the same direction to pass information from one neuron to others. So here I give a very simple example. So we have our FXI, that is this here is the price of let's say of the Bitcoin or other coin, and here we have our variables. So these three variables, this is constant. We have the market cap, we have the volume of transaction, we have maybe the interest rates or the dollar, and so on. We put whatever dependent variables we want, and here we need to have to initially put some waves of this value. That what's taking place. I will have some output functions with wave and input vectors, and then I will have an equation here. I have the real results. So the model will produce some equation by using these waves here and these variables, and then they get the final price prediction. Then they will compare this prediction with the real value, and then they will minimize this value. Then they will again correct these waves and go through this process until this error is minimized. And then they have one equation to predict finally the price of Bitcoin. So we can have a neural network far more complex than this one. So here you can see in the end they also have equation here as explained here. So you have a matrix here for the waves, you have a matrix here for variables, and the idea is that you have equations to make your regression, and that's the process go back forward to correcting, to updating the waves, and in the end you get a prediction with minimal error. That not means that's the error and the prediction that is performed by neural network regression will be better than linear regression. Depends on your data, and I insist on this point. That's very important. You have assessments that you considering the different models, and you are able to compare the error. So let's give me an example, very fast example to close this first presentation clarification about machine learning regression methods and how to apply that for let's say predict the one of your coins price in the future. So here we are in this coin market cap website. So just an example, you can get information from another website. This is the one that I get used. It's very simple. You just I click here in Bitcoin, then here there is an option here that I can download this data. Is very important to select here all. So here I get the information since 2012 until November this month. Then I get monthly price. I have a maximum price, minimum price. I have last closed price. I have market cap and other information, and I use these variables as I mentioned before to make my regression. So here what I did, I choose the price as an independent variable, the one that I want to predict, and I have the price here from the beginning. I use the volume of transactions, and I use the market cap as dependent variables. And then now what I did is I select, I exclude some columns here, and in the end I choose these variables for my regression model. Price, independent variables, volume of transaction, and market cap are the two dependent variables. So the next step now is that I will import this model for my model here. This is a regression learner. This is an app from MATLAB. So what I'm showing this one. So first is the easiest way that you can use artificial intelligence to indicate to prediction a coin price or whatever financial assets. And why? Because here in this model, I don't need to know any code. That is the advantage. That's why I'm showing the MATLAB. In a future, I will show also example on R codes, and you see that's not too complex. But by using this method, this model here, you don't need to know anything about codes because the codes are embedded in your selection. So basically here, what you do, import your data here in this new section here. Your data will be uploaded, and then this shows, for example, the relation between your response, that's your price, and your value. So you can see here that's the true value and the prediction. So the true value is in blue and the prediction is in yellow. So you can see that many points are very close, the prediction and the real value. And some points, yeah, you always will have outliers. And then, as I mentioned before, what you want to do is basically select here the model that better fits on your data. And the model that's better fits on data, as I mentioned, is the one that have a lower root mean square error. So if I compare, you can see here Gaussian process, neural network, you have different neural networks here, you have kernel, you have linear regression. So you can see that comparing the neural network, we have RMCE 442. When I compare with linear regression, that is 649. So the neural network regression methods gives a smaller error when compared to linear regression, when compared to all other models. And then I will choose the model that have the lower error, as I explained before. And then what's the next step will be? I will predict now what will be in the future. So since I have a model, now I want to predict the future. So I will explain in detail how you do step by step this example in the next video. I just want to clarify the concept that I present in this first video concerning machine learning regression. So I want to know the price. This is the price in November, the volume transaction market cap. So here I put some hypotheses. Then what if this volume and market cap increase 10%, 20%, 30% in the coming future, and so on? What will be my price? And that's what I want to know. What will be my price if I have an increase of market cap of 10%, 20%, 30%, or so on? And then by doing so, when I apply my model, so I import this model here, they predict this is plus 1 million. So I can see here the values that I will get in millions. So here I will have 105,000, 124,000. So this is the second value. So meaning if the market cap increases here, let's say 20%, I will achieve, let's say 124,000. And when will be that? It can be in January, can be in February. But that's the idea. And how can I investigate the increase of market cap or the volume of transaction? Can always follow up on the website as I shown, and I can get the news of a huge organization that will invest in Bitcoins, for example, and how much they will buy. So I will already have an idea how much will be the market cap and the volume of transaction. Then based on it, I will that's my idea that I'm doing here. I will know how much percent now that will be this market cap and this volume, and based on it I can predict the price here in this model. So, and that is the idea behind the machine learning regression. So as long as this, and then of course as long as this data is starting to be updated, the price starts to be updated in December, January, the model will do all this process again, and maybe we will have another model, and that's not a problem because it just imports the model and make a prediction. I don't deal with codes. I don't deal here with try to understand the model. I made an explanation about what's most of the model doing, some of them doing, for you have a clear idea. That's the logic behind. But in the end of the day, you need to be consistent. And in the end, you get your price prediction along the time here. You can see around 100 and so on based on time. That's a type of information that we get.